Hello friends, Arun here. Today my fresh Intune lab has a real compliance failure. Our authorized hacker Windows device is marked not compliant. In this live session, I'll show you the exact policy, the 3 checks behind it, the safe assignment, the device sync, and the final per setting result. No slides and no changes to any other device. I'm starting under Devices, then Compliance, then Policies. This tenant has one Windows compliance policy named Intune Lab Win Compliance Foundation Hacker. The long name is intentional. In a real environment, a clear naming convention helps an administrator understand the platform, purpose, and pilot scope before opening anything. The Monitor tab gives us the first important result. Intune has received a status from one device, and that device is non-compliant. Remember that a compliance policy evaluates a device, it does not automatically configure every security feature. If we require BitLocker in a compliance policy, Intune checks whether BitLocker meets the requirement. A separate endpoint security or configuration policy is normally used to configure BitLocker. Now I'm opening Properties. Our Windows 10 and later profile evaluates 3 device health signals. The first is BitLocker. BitLocker protects the operating system volume, and the compliance check uses Windows Device Health Attestation. Microsoft notes that this status is measured at boot, so even after encryption completes, a restart can be required before the device reports compliant. The second setting requires Secure Boot. Secure Boot lets UEFI verify trusted signatures during startup. A device that does not support the required attestation or that has Secure Boot disabled can report not compliant. I am not changing firmware settings in this episode because a firmware change deserves its own backup and recovery checks. The third setting requires code integrity. Code integrity checks drivers and system files as they load into memory and helps detect unsigned or modified kernel components. These are 3 different signals, so one can pass while another fails. Under Actions for Non-Compliance, the default action marks the device non-compliant immediately. This policy is not connected to Conditional Access yet, so today's status does not block sign-in to cloud resources. That separation is important for a beginner lab. First validate reporting, then plan enforcement with exclusions and emergency access accounts. Here is the assignment proof. The included group is IntuneLab Pilot Hacker, it is active, and there are no broad all users or all devices assignments. This keeps the blast radius limited to our authorized lab device. Back on Monitor, the policy shows one non-compliant device. I'm opening View Report, waiting for the current data, and we can see hacker with policy compliance status not compliant. Microsoft explains that compliance reporting depends on device check-in and policy refresh cycles, so a new assignment may not appear instantly. A device can also remain pending until it checks in. Now I'm opening only Hacker. The overview confirms that this is our corporate Windows lab device and its current overall status is not compliant. I'm selecting Sync. This is a supported on-demand action that asks the device to check in with Intune, receive pending policies and actions, and update compliance information. Sync does not guarantee that a disabled security feature suddenly becomes enabled. It only starts the check-in and evaluation workflow. After the sync request, I'm opening Device Compliance for Hacker. The default compliance policy is compliant, But our new Windows Foundation policy is not compliant. This is a useful distinction. The default policy and our custom policy are separate evaluations. Now for the exact answer. Inside the custom policy, Intune reports 3 settings. BitLocker is not compliant. Secure boot is not compliant. Code integrity is compliant. This is why we never guess from the overall red status. We drill into the policy and then into the individual settings. The safe remediation plan is clear. First, confirm that the hacker device has a usable TPM and that recovery information is protected. Then configure BitLocker through a supported Intune policy, validate encryption, and restart before rechecking attestation. For secure boot, confirm UEFI mode and hardware support before changing firmware. Do not make these changes blindly on a production device. Today we proved the complete path, policy, settings, hacker-only assignment, report, device sync, and per setting evidence. In the next episode, I'll show the pre-checks and a safe BitLocker deployment for this same hacker lab device. If this live troubleshooting format helped you, share your Intune question in the comments and I'll see you in the next lab.